Hi guys, Tin Man here. This is mainly for the guys on the forum. I started a new thread and it's called Our Point of View. Within 2 hours it had 30 replies, so it was quite obvious there was a few guys that had a lot to say, and that being on if the likes of the Bedini motor really works, Searle effect generators, pulse systems of any kind, can you actually get more out than you put in? Well, I don't believe you can within the pulse system itself. When you're doing things like this, if you're just starting out, or it's even not too late to learn if you're a seasoned worker on the pulse motor systems or solid state pulse systems, the best advice that's been given out is to listen to what people say and then try it out for yourself. So I'm going to use 2 examples here. You will so many times hear being said that you're going to need a scope and all this flash equipment to make measurements. That's simply not the case. I do have a scope. I hardly ever use it. The only time I use it is so I can see what's happening within coils or pulses, that sort of thing, and when I go and change it to see if there was any change within that part of the system itself. The only thing you need to make the achievements that can be made by anybody is a couple of good meters, and some digital or analog meters. Try and get the ones that have the built-in capacitors and don't mind pulses. If you've got ones that jump around erratically, it's just a matter of putting a cap in between the pulse system and the power supply, and then bridging your ammeter between that cap and your power supply. That will smooth out the pulses. So the other thing you need is some really good caps. Now, believe it or not, they look big, but they're only 10,000 microfarads, 63 volts. The reason they're large like that is because they're designed to put out a lot of amps. That was their job. This little cap here is nearly the same size as them. This is 10,000 UF at 40 volts. So they're not much smaller in actual size, but physically it looks a lot smaller. So caps around the 10,000 UF 40 volt do just fine. The only other thing you'll need is a good solid power supply that's capable of putting out a solid and very stable current. Adjustable ones are really good. This one's also got our amp reading on it as well, of course. So contrary to what people say about needing all this flash equipment, you don't. My best achievements have been made without the scope and without any flash pulse counting devices or anything like that. Just simple meters, good capacitors, a good power supply. Now I'm going to use this as an example. Some of you might have read on my previous videos, I've been getting a lot of comments and input from one certain user, and I'm going to use this because I believe if someone's going to make a comment on something of mine that I don't believe, I have the right to prove that it is how I think it is. So this user states that the most you'll get out of a pulse motor is about 30%. The rest is loss driving the flywheel or the rotor and loss in the heat in the coils. Okay, so what you do is listen to what they got to say, go out and try it and see for yourself if that's how it is. It's that simple. So we're pulling off a very stable power supply. Nothing changes within that power supply. We're going into a good solid bunch of caps with a set load. It's no good using a pulse motor for a load unless you put a cap between your meter and the pulse motor. Using light bulbs, very good load, very stable, very consistent. Let them warm up for a while and then take your readings. So now this bit of rag I chucked over this relay because it made a terrible noise on the last video, so I found out, so I'll just chuck that on there to shut that up. If you've got a decent reed switch, you won't need the relay. This relay at the moment, I've put a meter between the cap and my power supply, and then from the cap to the relay to smooth out the pulses. As you can see, the relay itself is drawing 30 milliamps at our 12.5 volts. So that's a loss in the system, but that's a loss that we can eliminate, and we can eliminate that simply by putting on a bigger reed switch. So we're going to take the power that this is using off of here, because we want a reading of what the pulse motor is doing itself. So what we're looking for is our 30% out of that pulse motor, which is apparently the best we can get, and that's going to the charge battery. We're not even going to worry about the charge battery here at the moment, although as you can see, our charge battery and that globe is nearly buggered, nice and black, blue flashes, but our charge battery is being charged, and of course the one off our little relay charger. So we're going to measure our watts going into here, not into the relay, because that can be eliminated. We're going to measure the watts coming out of the generator side that's going into the caps and powering this light. So if we've got 130 milliamps and we take off our 30 milliamps at our 12.5 volts, that means that this pulse motor is drawing 100 milliamps at 12.5 volts, 1.25 watts. We're currently getting out of the generator 10.5554, flicking a little bit. So we'll go looking at that. 10.53 is our average at 47 milliamps. So oops, we will go for the lower one, 46 milliamps at 10.53 volts. Gives us 4.84 or 0.484 watts. Now that in itself is already more than 30%, that's closer to 40% coming out of that pulse motor on the generator side. So we've done 40% already, and we haven't even taken into account the charge going into the charge battery. So this is just a point I wanted to make to you. Listen to what other people have to say, and then go out and see if what they said is actually how it is. Now, I've had pulse motors myself, just this one here you would have seen in a few videos, that will give me 75% return, and that was measured through a cap with a resistor across the cap via going through an amp meter, and then the amps and the volts gave us our watts. Batteries, lead acid batteries, the only thing I'd use them for is somewhere to dump your charge, nothing else. They tell lies, they've got rest voltages, they've got recovery voltages. They're the worst thing you can use to do measurements with. So just something I wanted to point out to you. Like I said, listen and learn, but the only way you will get the results that are accurate is to do it yourself and do your own measurements. So on saying that, you can clearly see we're already getting more than our 30% out of our pulse motor just on the generating side, which in itself proves that the generator's working, and we haven't even taken into account our charge going back into the battery, which I have measured, and with the generator side hooked up, it's putting in about 14 milliamps at our 12.94 volts. So if you really wanted to do the calculations on that, it's 12.94 times 0.014 and that's another 0.18 of a watt there to bang on top. So that's pretty much all we've got for this video. It's just a way of showing you guys that it pays to check things for yourself and not just go on what others say as being the gospel. Alright, cheers guys, thanks from the Tin Man.